Hey, welcome to Lecture 6 of the Standard course. In this lecture, we'll go into a little more depth into the other kind of approval criteria that can be defined on-chain. So in the last lecture, we kind of focused more on the approvals, the amounts, the trackers, and balances that can be transferred. And this will do like other miscellaneous criteria. So the first that you can do is you can define certain badge credits transfers to be, triggered upon each use of the approval. So this can be used to, implement like royalty systems or stuff like that. So you just define a to address and how much of the badge credits you want to receive per use of the approval. So this also might be used, maybe you transfer a little bit to the owner to, maybe cover gas fees too, just something along those lines. So next we also have like for collection level approvals, you can override the recipient or incoming approvals on the user level. You can, for like the mint address, you have to set this to true because obviously the mint address is not owned by anyone and it cannot set its own approvals. So you must override this. But you can also override it to implement maybe like forceful revoke systems by like a certified manager or something like that. And again, this is only available on the collection level. So next, we have ownership requirements. You can define, checking balances on chain for certain, like prove you own other badges on chain to be approved to transfer these badges. So this can be pretty powerful because you can create complex claim systems that, maybe you must be verified with another badge to, interact with this protocol. You must be a member of a certain country or citizen of a certain country to interact with this. And so when you create those nested systems, it does become pretty powerful and you can check it. One thing I will know with these ownership requirements, though, is you can only check the on-chain badges. So any off-chain balance types, the blockchain obviously does not have access to. And the second thing I want to know is also you can also check ownership requirements off-chain too via BitBadges claims or any other method. So again, it's a trade-off of if you want to check it on-chain at execution time or off-chain during the claim satisfaction time too. So next we have, you might want to assert that the initiator equals the recipient or does not equal the recipient or equals the sender or does not equal the sender. Pretty self-explanatory. Typically these will be false and just determined by the scope of the approval, but this can help you implement other more complex cases like, maybe you must gift the badge to another person, so it cannot be, you cannot send it to yourself or something like that. Okay, next we have Merkle challenges, and these are probably the most important or beneficial criteria checks on-chain that you can do. This is actually how we use the BitBadges claims or implement the BitBadges claims behind the scenes. So really what these are is that on-chain, we will define pretty much a challenge, which is a Merkle tree that has a root, and in order to use the approval, you must satisfy or present a valid Merkle path to the root. And this is done in the transfer message or transaction, but you can define what the expected proof length is. You can actually use the initiator address as like a leaf node, so this allows you to implement like whitelist trees. You can define if there's only one use per leaf, because once you submit a transaction with the leaf with the path on chain, the path is public because the blockchain is public. And then you can also host any other necessary information on IPFS or any other place you want. So the way we implement this off-chain for BitBadges claims is that each claim has a unique proof of claim code or proof of claim leaf that it corresponds to. And if you claim, pretty much BitBadges as a middleman will give you that claim code to use on-chain in the Merkle challenge. So you only get one claim corresponds to each code, and each code can only be used once on-chain. And that's kind of how we gate the bridge that gap on and off chain. So if you want to see the code for how to create Merkle trees, you can do so here. But it's all handled for you in the interface, so you shouldn't have to worry about this. And also, if you want to implement like custom codes or something like this, you can also use the codes feature in claims. So sure, it is like one step removed from being fully decentralized because we control these codes, but it functions as the same purpose. So like you can use certain claim codes here for sending to on or gating your criteria off chain. In the future, we will add a fully or like a self-hosted one interface, so you can actually do like a fully decentralized version off chain. But for now, you can either do it manually behind the scenes using this code, or just do it through claim codes, through BitBadges claim codes. Okay, and next we have the zero knowledge proofs. So these are, if you're unfamiliar with zero knowledge proofs, I'd recommend you check out CirCom, and it's pretty much a way to prove some computation without revealing inputs to the computation. So, I know in this case, like I know the private key that corresponds to this public key, or I know the preimage of this hash value, and it won't actually reveal the preimage. And what you can do is actually it's actually a fully customizable programming language, and you can create these circuits that have solutions that pretty much you post the circuit as a challenge on chain, or in a roundabout way. You post the verification key and other stuff on chain. And pretty much to be able to use the approval on chain, you must provide a valid solution to the circuit. So this could be used to implement anything from like, maybe like inheritance, like you prove you have the secret key to a will, or like you prove you have a certain key to transfer this, or I'm an authorized user of this, so on. It's completely customizable. This is a little more of an advanced criteria because it takes a little more, takes you programming the circuit, it takes you doing all this, but it is possible on chain. It opens up a lot of cool use cases for anyone who wants to dive deep into that. So as you see here, you would input the public inputs and the proof on chain, and it will verify everything on chain for you. So a very cool way that you might be able to leverage and implement your custom use cases. And lastly, we went through all the criteria in the last 3 lectures, but if any of that is not enough, and you want to actually extend stuff and approve or check more criteria and extend the approval interface on chain, you can also go ahead and extend the functionality with a Cosm-Wasm smart contract. So Cosm-Wasm is the smart contract framework that Cosmos SDK, which is the framework that BitBadges blockchain is built on, uses. So within your contract, you can hook into the badges module and customize stuff as needed. If you want, should only be used in advanced use cases, and if you have anything that you think needs added to the core approval interface, let us know. We're happy to add stuff, and because it's an ever-evolving interface. But if you do end up needing something more custom or something out of the box, that go ahead and just create a smart contract. There is the tutorial here under the BitBadges blockchain create a smart contract. So yeah, like I said, the approval interface and the token standard, we aim to be more of just like an API like, where you just customize the parameters and all the stuff is implemented for you. And we have added a lot of features, and we hope that these features are enough, and we'll continue to add more over time. But it is extendable, customizable in multiple ways, whether that is through your own Merkle challenges, through BitBadges claims, through custom zero knowledge proof solutions, and so on. Yeah. Again, if you have any questions about the approval interface, please reach out to BitBadges and let us know.